Alright, ladies and gents, today I'll be showing you how to send your first transaction onto the blockchain. So to do that, I will be coding REPL, and we want the ES6 version with Babel. Cool, now Babel has loaded. So the first thing we're going to do is we need to import some libraries that we'll be using. So today I'll be using libraries that are based on Bitcore, but is modified to work with the Dash network. Dash is cryptocurrency that is very similar to Bitcoin. And because I personally maintain these packages, I just prefer to use these. If you want to make it work for the Bitcoin network, it just takes a couple small modifications. For example, here you would import Bitcore lib, not Bitcore lib dash. So we will also need a buffer conversion tool. So this is a small package in npm that we can use to do the job. And one more thing we will need is Axios, because we'll be calling a blockchain API to eventually query transactions, addresses, and broadcast our transaction to the network. So I'm going to run the code. By the way, I didn't know if you know this, but you can actually import npm packages directly like this in REPL, which is super cool. So console.log bitcore buff Axios. Just make sure that we actually have these things. It's still importing. Great, looks like we have our packages ready. Oops. So first thing we need to do is set the network to testnet. The reason we need to do this is because we'll be sending test dash or fake dash. This is something the network provides for development purposes. We do not want to be sending real currencies at the moment. So I will make a random string and use it to generate our addresses. In the next couple steps, we'll be making a HD wallet by generating a master key from this password. A HD wallet is set up such that you can continuously generate new addresses from one master key, and this is more secure than your traditional address, which never changes. So master key equals bitcore hd private key from seed known bytes bitcore dot network dot testnet. So here I'm just saying that I want to generate a master key that works on the testnet. So one thing we need to do is we need to convert this string into a buffer. So const bytes equals bitcore.crypto.hash SHA-256. SHA-256 is a very commonly known and commonly used hashing algorithm in cryptocurrency and blockchain. So let's see if this has worked. Console.log, master key. Let's see what we have. Oh, this should be capitalized. My bad. Private key. Gotta watch my capitalization here. Okay, cool. So now we have a private key. In real life, you would never ever want to show this to other people. People who will have your keys basically have access to all your funds. Just a word of safety there. So the next thing we need to do is we need to generate some addresses from which we can send transactions back and forth to ourselves. So let's declare some indices. Start equals 0. Just default values. So let's say we generate the first address. We will send the funds from the first address to the second address. So one will be start and send at the same time. But as we continue to generate more addresses and send fake dash to ourselves, the send index will change. So let's say there used to be $10 here. After you send it to 2, this $10 goes here. So we're gonna need to iterate over the addresses that is generated from the master key by their index until we find one that actually has balance to send to the next address. If you're doing this in real life, you would actually just directly send it to someone else's address. But I think this way we kind of get to learn the inner workings of a hierarchical deterministic wallet a little bit better. So that's what we'll be doing. Okay, moving on. So we are going to need to loop over this and generate some addresses. Start. So I'm doing this right now, so we don't end up with an infinite loop. I'm only going to do this 10 at a time. And what we want to do in this loop here, make a little more space, move it up, is generate keys or public keys or addresses. Master key dot derive I. So this right here is the private key of the address that we'll be sending funds from. And this is the public address, which we can receive funds to, and which holds most of our funding. So I want to get this address. Let's see, we have all these things set up correctly. Console.log. Okay, so let's take a look at what we have here. We have our private keys. We have and we have our public key. Cool. The next thing we need to do is make a call to a blockchain API to see if the address that we currently have has any usable balance to send. So let's do this. This is the result of the API call. I have pre-formatted a template string here. So let's take a look at what this is. We go to this address. Anytime now. Okay. So this is the blockchain explorer for a Dash network. And notice how it has test in the URL. This is the blockchain explorer for the test net. So let's see if we can go to the real net. And this right here is the address for the real net. And these are actual blocks that are being mined. And if we wait a little bit longer, we'll see the latest transactions. But that's not what we want because we're currently on a testnet. So let's go back to that. So using this blockchain explorer, even using just the front end, we can search for addresses and transactions, which I'll show you how to do later. But we are actually using the backend to call data. So let's try this. So by calling this route, I'm basically querying the status of the network. As you can see, this is the current network version. This is how many blocks that was mined up to now, and some other data points. Cool. So I am basically trying to query a address. So let me put that in. So let's pick a public address that we have. Let's try this one. Okay, maybe we'll use the latest one. It's easier to copy. Cool. So I'm expecting to see zero balance, nothing received, nothing sent, etc., etc. And that is totally normal because we have not done anything to it yet. The next thing we need to do is go to the testnet faucet. What a faucet is that this is a tool that will allow you to request some Dash for testing and development purposes. And we have gotten ourselves some test Dash. So how this works on the back end is that there is a miner that operates on the testnet, and as you mine blocks, if you solve the latest block, you are awarded some currency. If you are on the real network, you'll be awarded Bitcoins or Dash or Ethereum, but since we're on testnet, this miner is generating magical test dashes, which they're generously giving away for people to use. Awesome. So if I now go back to this address, I might be able to see some different info. Cool. So as you can see, this is the transaction that got us our test dash balance of 1,000. Currently it's unconfirmed. So what if I look at this transaction here? This is the information that I have. Just waiting for this to get confirmed. Let me actually show you this on the front end. Okay. I basically just type in the transaction ID here, and we can see this is unconfirmed. And this is how much dash that I have in my address. The block mining and confirmation speed on testnet is actually a lot slower, so this is going to take a while. But it doesn't matter, eventually it will get confirmed, and we can use a balance, but for now, let's go back to the code. Okay, so balance equals rest.data. Let me actually double check the shape here. ADDR, what is the address that I used? It's right here. And paste here. So result, this is data, and I want the balance. Data.balance. Cool. Actually, I want the balance set. This is what I want. So you'll notice that this is unconfirmed balance, and it's like 1,000. And you'll see this is unconfirmed balance sat. Sat stands for Satoshis. It is a much smaller unit measurement, and you can convert back and forth. Because like 1 Bitcoin or 1 Dash is like super expensive, so it's kind of like hard to use. It's really hard to imagine like cups of coffee in Bitcoins because it's like 0.000 something. So this is why we have a different smaller scale measurement called Satoshis. And that's what we want to pull off of the data here. So send index equals, actually send index equals I. Oops, that's not what I want. What I'm doing here is basically update an index so we can continue this loop. If balance is not 0, that means we have available balance. What we can do is break. So I'm basically looping through these indices 10 at a time until I find one address that I generated that has available balance. Right now it should be 0, or actually no, right now it should be 10 because that's the one I used. And we're gonna say console.log break out of loop and balance. Cool. Let's take this for a spin. Oops, syntax error. What happened? $24. Let's do this. Okay. So what we need to do is package this into a asynchronous function because we're making API calls and that is a asynchronous action. So let me say send transaction equals async. And wrap it up here. And now I have to call my function because this is no longer just going to execute by itself. So here we go. I think this should do it. Okay. That arrow function, not an equal sign. Okay, so our loop appears to be working. So far we have found the early user address that has a available balance. What we need to do is basically generate another address for us to send our balance to. So let's do that now. Okay, so I see what I'm doing here. Silly me. I'll put this outside of function. Wow, damn it. So what I'm doing now is I'm driving the receiver address and I'm converting that to a address from a private key so we can eventually send funds that way. So private key, receive, pub equals. Okay, cool. So we now have a receiver key. So we have a address where we're sending the funds from. We have a address where we're supposed to receive the funds. So we can now proceed to the next part. So if we look at the address here, we need to make sure we reference the right incoming transaction that gave us the funds. So anytime you have a transaction on the blockchain, the transactions themselves also chain together. So first of all, we need a incoming transaction, and that's gonna give, that's gonna go into a certain address, public address. And what you need now is to say, I'm going to send the funds from this public address into another address, another public address. Receiver. And before you can do that, we need to sign the new transaction. So this incoming transaction, we need to find basically ensures continuity of the transaction chain, and also tells us that in this public address that we're sending the funds from, there is actually valid usable balance. So maybe I should make it more specific, sender like that. Okay, so let's go find this incoming transaction. To do that, we are going to need to make another API call to the same API, but a different endpoint. So let me just test this string here. Get rid of that backtick. Actually, while we're here, let's see, we have had our transaction confirmed. I think it's been long enough. And yet I am wrong, it's still unconfirmed. Anyways, just give it a little more time. Let's take a look and make sure this endpoint is correct. Cool. This is fine. So now what we need to do is pull off the latest transaction, or at least reverse the order of transactions. So let's see what we have here. Cool. So as you can see, we have three transactions, and they're in the reverse order of, actually they're in the order of recency because we reversed it. Typically, these transactions are listed in historical order, but we actually want the opposite. So the next couple things we need to do is find the right transaction. So we need to iterate over the transactions. By the way, this shorthand, TX, this is the standard shorthand for transactions in the cryptocurrency world. And obviously TXS is transactions, which is array. So what we're trying to do now is that we need to make sure we find the one that has the right output. So if we look at this endpoint, change this to tx, paste in the transaction endpoint. We need to make sure that this is a transaction that is incoming. And the way we can tell is that if our address shows up here in transactions be out and script public key and addresses. We'll go over the importance of these hex later because we will be needing it. So as you can see here, this is the incoming transaction that eventually generated this outgoing transaction, which went into our address. And that's what we did was this testnet faucet request for funds. Cool, so let's do that. Let's set up some indices and variables first to keep organized. Tx in. This is the incoming transaction. Let's tx in index. This is the index of the transactions that we want in the list of transactions. And this will be the script that we're looking at here. Once again, we need to make another API call, so we'll use async await axios .get, and let me actually test this first. Just grab it right here. We need to replace this with the current tx. So we'll use template strings and say tx here. Tx data equals rest.data. Just testing our code. Okay, so there's something that REPL doesn't like, so we need to do a little more debugging. Let's try that. Of course, I spelled this wrong. Cool, so we're actually getting valid data back. Great. So each incoming transaction or each transaction can have multiple additional transactions that are outgoing. So this is why we need to do a loop. In the example we're looking at right now, there's actually already two. So this is why we need to loop over them to find the right one. Usually what happens is there is a receiver address and there's a change address. So let's say I have $100 in my account that I'm sending money from, and I only want to send $10 to my friend. So there will be two of these VOUTs. One is actually going to go to my friend, and the other one is basically whatever's left over. That's going to go to my other address, my change address. So it's kind of like the change going back into my pocket. So for each of these, what we need to do is VOUT dot script pub key dot addresses, yes, is equal to send pub dot to string. I mean this to string because these are like not exactly strings. They have like weird headers and stuff. So I actually just want a string. So if the two matches, that means this is the incoming transaction that we can reference to build a new valid outgoing transaction for this current address we're sending our funds from. So we need to basically fill in all of this, which we will use to generate our valid transaction in the next part. So tx in equals the current transaction going back to here. This is the number we want. This is the index number. Yeah, that's public dot hex. And this is the hex of the full transaction, which once again we will need to build our valid transaction. So set is Satoshis. So let's actually define that variable, set. Once again, Satoshis is just a smaller unit measurement for cryptocurrencies because a lot of these cryptocurrencies have a very high value. So value times, I'm pretty sure conversion is at this scale. QQ. So now we can go ahead and construct our valid outgoing transaction. So var utxo and this stands for unspent transaction output equals tx. Just building a normal JavaScript object here. Here's the key, and here is the value tx in. What else do we need? We need the output index. Output index tx in index. And spelling matters. I'm such a terrible speller. Address half the time I'm like spending minutes looking for typos. This is why linting is very good. Scripts. And this is the hex that we put off, or we grabbed from here. So I'm gonna copy that. Great. And Satoshi is just set. Cool. Now that we have this, let's just console log it to make sure it looks about right. Okay, so something is not going right here. And it's kind of annoying that it doesn't tell me what the problem is. Right, this is TX, not text. Okay, hopefully that's it. Okay, sick. So we have our transaction ID here. This is the index. This is the address it's being sent to, and here is our key. And this is how much money we have. So now that we have a verifiable proof that we did have an incoming transaction, back to this. Now that we have this part, we can now try to build the rest of it and then sign the transaction and then eventually broadcast it. So let's do that. Const transaction equals new bitcore.transaction. By the way, there are multiple JavaScript libraries that will help you interface and work with the blockchain. So Bitcore is a very popular and industry standard one. There's also Bitcoin or Bitcoin.js, which is newer but also very, very popular. So many ways to shave a cat. Feel free to pick whatever library you prefer, but most of them will have similar ways of doing similar functions. So there's one thing I kind of want to explain here. Satoshi, as we mentioned before, is the balance that you have in the address you're trying to send. But what is this number here? This is actually a fee that we pay to the network to send our transaction. And this is part of a network sustainability strategy. So not only do miners receive funds from mining, sometimes they also receive funds for dealing with broadcasting transactions, verifying them and sending them out. And as the mining reward slowly declines, it's really important to have these transaction fees to provide enough incentives for the miners to continue doing their work. Because really the miners kind of uphold the integrity of the network. And we want to make sure that they're properly compensated, so there's enough people interested in doing that work. So now that we have this transaction that we built, basically what we're saying is, hey, I want to make a new transaction. Here's the incoming transaction that I'm referencing, which we figured out here. And here is the address I want to send funds to. and the amount I want to send is everything that I have except for this little bit, which is the fee I'm paying to the network. And the last and most important part is that I'm signing the transaction using the private key of the public address that the funds are coming from. So private keys and public keys are in pairs. So you use the public key as address, and you use the private key as kind of like verification that you're the rightful owner and you have control of the assets in that address. So now that we have this, let's do a console.log. Let's console log this transaction here, and let's do a toString. So we get the raw object, and I'm gonna say tx, just so I know what I'm looking at. We're console logging a lot of things. Q, we're almost there. Let's take this for a spin. Awesome. So we have this. This is the hex representation of this transaction. And we are going to do our last little part. Now that we have a transaction that we built that contains all the information the network needs to process it successfully, we still need to broadcast it and make a call to the network to actually send it off. So for that, we're going to do axios.post, spelling again, axios.post, post. And the endpoint for this is actually this right here. So this is once again a transaction related endpoint, and what we're hoping to do, the action is send. And now we need to provide the information that we work so hard to generate. So raw tx, and this is just the standard way of saying this is a hexadecimal version of the transaction I want to send, which contains all the information you need to process this request for me. Then, so if this succeeds, let's console log success transaction ID. So if the post operation is successful, the network will actually give us a transaction ID that we can later use to look at or inspect in the blockchain explorer. So let's go back and take a look at our actually this is probably better. Okay, so here, oops, missed it. Here's our transaction. Has it been confirmed? Oh, still unconfirmed. That's okay. So before this demo, I actually loaded up some test dash previously. So we should have funds to send. And this is also why the IDs and indices you're seeing here may not match what exactly this is. I just didn't want to have to wait for the whole thing. So so what we want here is response.data.txid, and we are cool. And should this call not succeed, yeah, I'm doing something wrong here. Cool. Catch. If we have error, we also kind of want to know about this. Function er console.log error. frowny face. Was a mustache. Actually, just frowny face. ER dot response dot data Q. So let's take this for a spin and see what happens. Okay, cool. So we are able to make a successful call to the network with this transaction hex that we worked so hard to build, and the network actually gave us a transaction ID back. So how exciting. Let's go take a look at this transaction. Maybe I'll do it here. So this was sent at this time. Let's see, exactly 11:03. And it is still unconfirmed. But at least we're able to do this.